Hi class. The nature of our remote learning is that there's a high expectation that you participate in a lot of learning activities. One of those activities is labs, experiments, using household items. Especially because this is the first one, I'm going to perform the activities in case people don't have the supplies to perform part or all of the activities from the investigating the properties of water experiment. You will be expected to complete this as an assessment for this first activity in Unit 1. You're performing a lab using household materials. Again, if you don't have them or don't have the opportunity, you can use this video, pause it as you need to, rewind as you need to. Using these household materials to investigate the properties of water. As you prepare for, perform, and report about your investigation, look for opportunities to practice good organizational skills. Look for ways you can present data and observations clearly and comprehensively. Finally, practice using vocabulary related to biochemistry to describe biological molecules. For your write-up, you will 1. Be typed using spell check, table making functions, and headings. 2. Include thorough observations. Again, you can make observations based on what I filmed here this evening or your own at-home experiment. Include pictures of each of your results. You can use the snippet tool to capture images of my results, or if you do the experiment yourself, capture them with your phone or another camera device. Summarize your results using concise language and a neat table. For quantitative observation, put units only in the column headings, for example, milliliters. If you used internet or paper sources, reference them at the end of your report in the section titled References in APA format in alphabetical order. Offer detailed explanations using relevant scientific specific terminology, examples, and references, and the corresponding relevance of the results to living things. So, there's a lot to do, and there are 5 parts to this activity or experiment, and I'll begin now. Welcome to part 1. How much water will a coin hold? Obtain a clean, dry coin, place on a flat piece of paper towel, fill a glass with water, simple tap water, and dip a clean finger into the water and drop it onto the coin. Continue to add drops, dipping the same finger into the water as needed, counting the drops until it overflows. The drop that overflows doesn't count. Record the amount of water. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, so 26 doesn't count. We're down to 25. The second portion of the experiment is dry the coin and to coat the coin with a very thin layer of dish soap. So finishing up drying the coin, making sure I'm still in the window of view, and then I'm going to add some dish soap, a thin layer. The experimental procedure wasn't clear, so I'm going to coat both sides of the coin, although I have a feeling one side won't matter nearly as much. Oops, I misfired. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That was kind of a mistake. 12, 10 or 11. So significantly less on that round. So your goal is to talk about cohesion or hydrogen bonding and surface tension. This is part 2 of the experiment, and we will do water drop shapes. We're going to use a clean plate and a square of wax paper. Once again, we have a glass of water. We will dip a clean finger into the water and then do a single drop onto the plate. It's very difficult probably for you to see, but the drop has spread out from the center in a circular pattern. Now we'll take a drop and place a drop here on a wax paper. This is once again very difficult for you to see. But there is a little ball of water. You'll have to have faith that that was the drop that I placed on the wax paper. Your job for this portion of the experiment is to discuss the term adhesion, the formation of hydrogen bonds between molecules of different types, and hydrophobic interactions. You may do this later when you complete your write-up. Part 3 involves taking a coffee filter, folding it in half to make a circle, folding again to make a quarter circle, one last time to make an eighth of a circle. I've done this already. We need to measure exactly 1.5 centimeters from the tip of the point up. I've done this and marked it with a water-soluble marker. I marked it twice with a little gap of time in between. Next, I measured exactly half a centimeter of water in the bottom of this glass. And my job is to insert the folded coffee filter with the point and ink down. The ink dot should be 1 centimeter above the water. Then we'll observe what happens in 15 to 20 minutes. So I'll place it now, and instantaneously you will jump forward in time. Part 3, Part 2. My third experiment has come to a conclusion as I've reached well over 20 minutes. And as far as the marker, there's very little evidence that it was here. Now, I'm not sure if this was an error brought in by my marker, if the marker was supposed to dissolve, I suspect if you repeat this experiment with another marker, you would see a pattern. Earlier in the time frame, I was seeing marker bleeding up. I suggest that if you have a coffee filter, water, and a way to measure, like a ruler, that you repeat this experiment to come up with some very good answers to part 3. Part 4 of the experiment involves filling a glass with 2 centimeters of 70% isopropyl alcohol and 2 centimeters of plain tap water, and then adding an ice cube. It may be difficult to see, but I can tell you that the ice, and this is water ice, inside the isopropyl alcohol or rubbing alcohol, is resting or floating on the bottom of the glass. The ice is floating in the tap water. This is a hypothesis you may have come to before we conduct this experiment. Either way, explain the effects in terms of polarity, density, and the role of hydrogen bonds. You may want to do this after. You can pause the video and have a look. In part 5, solubility, I mixed teaspoons of sugar into this water. I only got up to 4 or 5 and decided that I could continue to dissolve sugar for a very long time. I made an attempt with 1 teaspoon into the vegetable oil, again a quarter cup, and the sugar doesn't seem to be dissolving at all. I know that's difficult to see. This is a great one to repeat on your own. So with part 5, solubility, we want to determine what is physically happening when we say something is dissolved. Explain your results in terms of hydrophobic interactions, intermolecular force of attraction, and hydrogen bonding. Let me do this right after the video.